Okay, today we are going to learn how to prove that quadrilaterals are parallelograms, and there's a couple different ways to do that. So let's go over and sort of review some of the facts we know about parallelograms, because those are what we're going to use to prove that they are parallelograms, or I'm sorry, that quadrilaterals are parallelograms. So if we know that both pairs of opposite sides are congruent, then we know it's a parallelogram. So what that means, draw here, is if we know that opposite sides are congruent. So opposite sides, and actually we already know that, it's already there. So if we know the opposite sides are congruent, that means we have to find the length of each side. So that's using distance formula. So that's one way we can show that they are. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So that's just something they'll have to tell us, or we'll have to use algebra to figure that one out. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So this one we could use distance formula. We might have to use midpoint formula for this depending on what we're given. And the last one says, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So to prove that they are parallel, we would use slope formula. And to prove that they are congruent, we would use distance formula. Okay. We have one more theorem. It says if an angle of a quadrilateral is supplementary, to both of its congruent angles, then the quadrilateral is a parallelogram. All right, so now here's different ways that we can show that a quadrilateral is a parallelogram, or ways to prove. So first we could show that both pairs of opposite sides are parallel. And remember, anytime they're parallel, we use slope formula. We could show that both pairs of opposite sides are congruent. We can show that both pairs of opposite angles are congruent. And that one we might have to use algebra. We could show that one angle is supplementary. Remember, supplementary is equal to 180 degrees. We could show that the diagonals bisect each other. And finally, we could show that one pair of opposite sides is congruent and parallel. I will say that typically this is the way most students prefer, or they prefer just showing that opposite sides are parallel. All right, so moving right along. First example, and this is the one that's going to take the most time, because I'm going to show you 3 different ways. Just know that when you go to the your turn, you can pick your favorite way, so you don't have to solve each problem 3 different times. I'm just going to show you 3 different ways here. So it says show that A, B, C, D are the vertices of a parallelogram. So the first way we're going to use, and remember, you guys pick your favorite once we're done with all 3, show that opposite sides have the same slope. So to show that they have the same slope, don't forget slope is rise over run. And we could go about using the slope using these points. So I would have to do like A and B. Then I would have to show that that's equal to C, D. Okay? So I'd have to show that these 2 have the same slope. Then I would have to go through and show that these 2 have the same slope. And we can use slope formula. However, since they gave us the picture, we're going to use rise over run because that's going to be our easiest way. So I'm going to do AB first. Then I'll go CD because those two should be equal if it's a parallelogram. So I'm going to do my rise over my run. So 1, 2, 3, 4 over 1. So C to D is 4 over 1, which is just 4. And then A to B over 1 up 4. So again, rise over run, so that is 4 over 1, so that is 4. So those two check out. But now we have to do C to B and D to A. All right, so D to A and C to B. So I'm going to go down, cross to make my triangle. So down 2, well, that's negative 2. And then to the right, 1, 2, 3, 4, 5. So D to A is negative 2/5. Now C to B, I'm going to go over 1, 2, 3, 4, 5. But then I'm going down 2. Don't forget, down is also negative. So we also do rise over run. So that's also negative 2/5. So first method, done. That's why this is sometimes the favorite to some people. All right, now I guarantee this next one's probably going to be your least favorite, but we're still going to do it anyway. I'm still going to show you how to do it. So, show that opposite sides have the same length. Get that? All right, so opposite sides. So that means I'm going to have to do distance formula 4 times. So I'm going to start with AB. Okay, so A to B. So distance formula, I'll write it off to the side here. So we do x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and then square root all of that. So I'm just going to use the points. So I'm going to do AB first. So I'm going to do 3 minus 2 squared plus 4 minus 0 squared. So I'm going to get 1 squared plus 4 squared, and we get the square root of 17. I'm just going to leave it in that format. So that's AB. Now C to D should have the same length, so I'm going to do C to D next. All right, so C to D, so that's going to be negative 3 minus negative 2 squared plus 2 minus 6 squared. So those two negatives make it positive, so we get negative 1 squared plus negative 4 squared. So we get 1 plus 16, which is the square root of 17. So that one works out too. All right. Now let's look at the other two sides. So we're going to look at C to B and D to A. So C to B, right, so I'm using those two up top. C to B, so I get negative 2 minus 3 squared plus 6 minus 4 squared. So I'm going to get negative, I'm multiplying negative 5 squared plus 2 squared All right, so we get 25 plus 4, and we end up getting the square root of 29. Now, that's not the same length as the other two, but that's okay, because we're not trying to prove that it's a square, we're trying to prove that it's a parallelogram. All right, and now we have A to D to do. All right, a to d. So we have negative 3 minus 2 squared plus 2 minus 0 squared. So negative 5 squared plus 2 squared. And we already know that's going to be 25 plus 4, so the square root of 29. So all of this work is what you would need for this problem, because that's showing that opposite sides have the same length. So that's a good little bit more work than the first method, if we have the picture. All right, and last but not least, we have to show that one pair of opposite sides is congruent and parallel. So for this one, we actually already know all of this information, but I'm still going to go through and do it. So one pair. So you either need to pick AB and CD, or you can pick AD and BC. You don't have to do all four. You either pick the first two or the last two. I'm going to go ahead and do the first two. So for the slopes, because we have to do the slope of each, and then we have to do the length of each. Okay, so we have to do both. So we're still doing 4 things. If you notice, every problem we've done 4 things. 1, 2, 3, 4. If we look at the first one, 4 slopes. So no matter which method you use, you have to prove 4 different things. So the slope of AB, if we did rise over run, that's -4, -4. And then if we were to do the length, remember that's our distance formula. We found that each of them were 17. Now typically we would actually have to do these to prove them. You have plenty of room there, but since we already did them, I'm not going to make you do them again. Oops, sorry, square root of 17. Oh, and this is +4. I apologize. I was looking at the wrong problem. So both slopes are +4, and both lengths are the square root of 17. All right, so now pause the video, try the your turn, and come back. All right, so for this one, let me get my black one, make it a little bit thicker. If you look at all the points, they're negative. So it's easiest if you put your XY axis. Oh, that's really thick. It's a little too thick. Toward the left, and then I put it 2 down from the top, and it fit pretty nicely. All right, so A is -3, 0. B is -2, -4. C is -7, -6. And that was C. And D is -8, -2. So just by looking at it, we can sort of tell that it looks like a parallelogram, but we cannot say, and none of our methods were, yes, it looks like one. So we have to prove it. So I'll do a little bit more here for you guys. I will do both sides. That way, no matter how you did it, you'll be able to check your work. So AB, this slope, is -4. The length of AB is the square root of 17. If you did DC, the slope, that's -4, and the length of D to C is also the square root of 17. Now, if you did AD, the slope should be 2/5, and the distance is the square root of 29. And if you did B to C, the slope is 2/5, and the length is the square root of 29. Okay. Now for B, you had to sketch it if you had a sheet of graph paper somewhere, or just sketched it on there, just so that way you can see which sides are opposite each other. So I'm just gonna sketch it here quick just to show you guys that it's not too bad to sketch it. So -4 up 1, well there's A, over 1 up 2 is B, over 4 down 4 is C, and -1, -5, which mine looks pretty bad. Okay, we'll just, I don't quite have mine. So anyways, we get an idea. I'm gonna move this one down. Mine doesn't look very much like a parallelogram, but if you look at the directions to show that the quadrilateral with the given vertices is a parallelogram, so we can sort of just find out if it is. If we don't get the same slope or we don't get the same distance, that means it's not. But this right here was just to show me which sides are opposite each other. So I'm going to do, again, you don't have to do all 4, but because I don't know what you guys did, I'm going to tell you all 8 answers. So I'm going to do the slope of each side and the distance for each side. So if we do AB, the slope, you should have had 1/5, and the distance or the length of AB should be the square root of 26. CD is opposite that one, so the slope of CD is 1/5, and the length of CD is also the square root of 26. If you do the other two sides, so that's AD and BC, so if you did the slope of each of those, each of their slopes are -2. And then the length of each is the square root of 45. All right, so you should be able to check that one. All right, last example. Of course, we have to use a little bit of algebra here. So it says find x so that the quadrilateral is a parallelogram. So one of those facts, if you remember, is that it's a parallelogram if opposite sides are parallel and congruent. Well, we already know they're parallel because they put those 2 little arrows. So now we just have to show that they're congruent, or find x so that those 2 are congruent. So what that means, if they're congruent, that means AB will equal DC. So substitute in what we know. So 4x minus 1 equals 3 times the quantity x plus 2. We have to go ahead and distribute. All right, I'm going to add 1 to both sides, so I get 7. I'm going to subtract 3x from both sides and get x. So x is equal to 7. And you can check this by substituting it in. All right, so take a moment, try this last your turn, pause the video, and then come back and check. All right, so we found that M is 6. All right, so you guys can see your practice work after this, so go ahead and get started.